today, this webinar time, I hope you are ready for webinar. Okay, just let's start from these words. And let me check something here. Okay. Hi, welcome to our free webinar about CISCO Networking Essentials. It will be the first free webinar and the first part of the topic. I'm Ersin Tezbasharan. This is the just first step of Networking Essentials. It will be some terms and definitions with pictures. Additionally, we have a small quiz in the slides. Communication of computers allows to share, send, and receive data between them. Most of the people don't aware how the connection is defined. Yeah, if I can ask this question, everything is okay? Can you hear me? Can you type on the chat box, please?
Yes, I hear you, sir.
Okay. Anyone? Just if you hear me very well, and you can see and watch it, just on the chat box, you can write everything is okay. Thank you very much. You can hear us. Okay, let's continue. Now, let's know what CISCO is. The name CISCO was derived from the city name San Francisco in the US, which is why the company's engineers insisted on using the lowercase CISCO in its early years. The logo, is intended to depict the two towers of the Golden Gate Bridge. And Cisco Systems Inc. Inc. is incorporated, is an American multinational technology corporation headquartered in San Jose, California, in the center of Silicon Valley, that founded in December 1984. And Cisco develops, manufactures, and sells networking hardware and software, at the same time telecommunications equipment and other high technology services and products. Cisco specializes in technology markets such as Internet of Things, IoT, domain security, and energy management, with some subsidiary companies such as OpenDNS, WebEx, Jabber, and Jasper. And this is the first part of our CISCO Networking Essentials. The goal of this webinar is to introduce you to fundamental networking concepts and technologies by the reference of CISCO Networking Academy and netacad, that is short name. And there are 10 chapters inside of the CISCO Networking Essentials course. Chapter 0 gives some information about the course as a message to students. Chapter 1 introduces to networking to build enough background and so on. I'm going to start with chapter 1 today. We have 30 slides totally. There is one activity, just a small quiz. I hope you will be well informed at the end of the webinar. When we complete the first part of CISCO Networking Essentials today, you should be able to explain the concept of network communication and explain the roles of devices in a network and build a functioning network. So, what is network? We expect our devices, cell phones and tablets and laptops and desktop computers to always be connected to the global internet. We use this network to interact with our friends, shop, share pictures and experiences, and learn. Normally, when people use the term internet, they are not referring to the physical connections in the real world. Rather, they tend to think of it as a formless collection of connections. And it is the place, actually, people go to find or share information. So network is a large system consisting of many similar parts that are connected together to allow movement or communication between or along the parts or between the parts and a control center, according to the Cambridge Dictionary. The internet is, let's give some information about that. The internet is a worldwide connection of interconnected networks, or we can say internet work, cooperating with each other to exchange information using common standards. Through telephone wires, fiber optic cables, wireless transmissions, and satellite links, internet users can exchange information in a variety of forms. Everything that you access online is located somewhere on the global internet, social media sites, multiplayer games, and messaging centers that provide email, online courses. All of these internet destinations are connected to local networks that send and receive information through the internet. As you see on the figure, the guy is working with the PC and is connecting some internet connection. Yeah, there are some types of network defined by Cisco under local networks. It can be made in different categories. As you see on the figure, there are 4 different pictures there. And one, small home networks. The second one, small home office networks. The third is medium to large networks. Fourth one is worldwide networks. Let's give a few definitions about that. The first one is the small home networks connect a few computers to each other and the internet. The simple one. The second one is the small office, home office, or SOHO, the other name is SOHO network, enables computers within a home office or a remote office to connect to a corporate network or access centralized shared resources. Medium to large networks, such as those used by corporations and schools, can have many locations with hundreds or thousands of interconnected computers like university. The internet is a network of networks that connects hundreds of millions of computers, we can say worldwide. And if we talk about transmitting data on the network, customer data, personal data, health data, census data, but what exactly is data? If we give the simplest definition of data, is that data is a value that represents something as numbers, formulas, alphabetic characters, and pictures. Most people use networks to transmit their data in order to share with others or for long-term storage. Every time we hit send or share in an app or computer application, you are telling your device to send your data to a destination somewhere on the network. As you know, computers and networks only work with binary digits, zeros and ones. It can be difficult to imagine that all of our data is stored and transmitted as a series of bits. Each bit can only have one of 2 possible values, 0 or 1. The term bit is an abbreviation of binary digits and represents the smallest piece of data. Humans interpret words and pictures, and computers interpret only patterns of bits. And every input device, mouse, keyboard, and maybe voice-activated receiver will translate human interaction into binary code for the CPU to process and store. Every output device such as printer, speakers, and monitors, will take binary data and translate it back into human recognizable form. Within the computer itself, all data is processed and stored as binary. And after the data is transformed into a series of bits, it must be converted into signals. Signals may be converted many times before ultimately reaching the destination as corresponding media chains between source and destination. There are three common methods of signal transmission used in networks. These are simulated in the figure. And the first one is electrical signals. If we say something about that, transmission is achieved by representing data as electrical pulses on copper wire. Optical signals, transmission is achieved by converting the electrical signals into light pulses. And the last one is wireless signals. Transmission is achieved by using infrared, microwave, or radio waves through the air. In most homes and small business, network signals are transmitted across copper wires, as you know, cables, or Wi-Fi enabled wireless connections. And larger networks employ fiber optic cables in order to reliably carry signals for longer distances. So, if we say something about streaming, a movie or playing a multiplayer game requires reliable and fast connection. In order to support these high bandwidth applications, networks have to be capable of transmitting and receiving bits at every high rate. So what is bandwidth? Bandwidth is the capacity of medium to carry data. Digital bandwidth measures the amount of data that can flow from one place to another in a given amount of time. And bandwidth is typically measured in the number of bits that theoretically can be sent across the media in a second. And common bandwidth measurements are, thousands of bits per second. We are saying that kilobit per second, and millions of bits per second, megabit per second. And the last is, today we will mention it, billions of bits per second and gigabit per second. We should not confuse that MB, megabyte and megabit, kilobyte and kilobit. This speed of the internet and bandwidth is measured by kilobit and megabit and gigabits. Okay. The other words about the speed of measuring, like bandwidth, we have throughput, and this is the measure of the transfer of bits across the media over a given period of time. And however, due to a number of factors, throughput does not usually match the specified bandwidth. Many factors influence throughput, including, for example, the amount of data, it being sent and received over the connection, the types of data being transmitted, the latency created by the number of network devices encountered between source and destination. Latency refers to the amount of time, including delays for data to travel from one given point to another. In an internetwork or network with multiple segments, throughput cannot be faster than the slowest link of the path from sending device to the receiving device. Even if all or most of the segments have high bandwidth, it will only take one segment in the path with lower bandwidth to create a slowdown of the throughput of the entire network. So there are many online speed tests that can reveal the throughput of an internet connection. You can check from there your internet connection speed. The figure also, this is an example, the figure displays the upload and download speeds. As you see here, the download speed is 80.78 megabit per second, and the upload speed is 8.78 megabit per second. There is also dial pointing at approximately 70 megabit per second. So let's make it colorful, our webinar, and we have too many times. We have 4 review questions. I will show to you some words or terms. You will choose only one answer for each. I think it will be 2 minutes, it's enough. And you can see on the screen and on the chat box, you can answer it with the numbers and the term, okay? These are the terms at the right side of the slides. Let me read for you. Throughput, internet, bit, byte, bandwidth, and speed. And these are the definitions about these terms from the left side. And please don't hesitate to answer them. Just type the answers with numbers on chat box. Okay, we are starting to time. I'm waiting your answers. You can read it and you can write on the chat box. At the same time, I will check my chat box. Okay, let's continue. Okay, just a few minutes. I think it will be very easy for you because some things we talked about that. And if you have any background about these network essentials, you can also answer these questions. Okay, very nice. One of you answered all of them. And one of you also answered just one of the questions. I'm waiting for you. You can write on the chat box. Okay. Let us use a little bit more time. We are waiting for you. Okay, one of you type that directly. Okay, you can write, don't hesitate anything, just you can write here. Don't worry, I will not tell your name. Okay. Just small more time. Mr. Collins, thank you very much. You are very fast today. Okay, just a few seconds, and after that we will answer the this poll activity. Thank you very much all. I hope you tried that. Maybe you don't have enough time to write. Okay, let's continue from answers. And you know, the first one is the global IP network that results from the interconnection. If you see that, this definitely is the internet definition. And value of 0 or 1, we are saying that bit, binary digit. And the third one is measurement of theoretical speed. We are saying that bandwidth. And the last one is, as you see, throughput, measurement of the rate. Okay. I hope you understand here. Thank you very much. Let's go. And all computers connected to a network that participates directly in network communication are classified as hosts. Hosts can send and receive messages on the network. In modern networks, computer hosts can act as a client, as a server, or both of them. The software installed on the computer determines which role of the computer plays. And servers are hosts that enable to provide information like email or web page to other hosts. Each service requires separate server software. For example, a host requires web server software in order to provide web services to the network. Every destination that you visit online is provided to you by a server located somewhere on a network that is connected to the global internet. And clients are computer hosts that have software installed that enable them to request and display the information obtained from the server. And an example of client server, client software is a web browser such as Internet Explorer, Safari, and Chrome, and Mozilla Firefox. And in communication of servers and clients, we have three figures that show multiple clients and servers all connected to the same switch. With the file server and clients, the file server stores the file. As you know, clients access the file with client software, such as Windows Explorer. With the web server and clients, the web server runs server software, and clients use email software such as Microsoft. Sorry, I think maybe I confused that. Clients with the web server and client, the web server runs server software. Clients use browser software such as Windows Internet Explorer to access web page on the server. With the email server and client, the email server runs server software. Clients use email software such as Microsoft Outlook to access email on the server. A single computer can run multiple types of server software. In a home or small business, it may be necessary for one computer to act as a file server and web server and an email server. A single computer can also run multiple types of client software. There must be client software for every service required, with multiple clients installed. A host can connect to multiple servers at the same time. For example, a user can check email and view a web page while instant messaging and listening to the internet radio. So the network path that a message takes from its source to destination can be as simple as a single cable connecting one computer to another, or as complex as a network that literally spans the globe. And this network infrastructure is, this network infrastructure is the platform that supports the network. It provides the stable and reliable channel over which our communications can occur. So the network infrastructure contains three categories of hardware components. Maybe you heard that before. The one is intermediate devices. The second is end devices. Third is network media. The intermediate devices are routers, wireless router, switch, wireless access point, call manager, firewall, service provider switch, as example in the figure 7. And figure 8, titled examples of end devices are a laptop, and printer, tablet, smartphone, iPhone, desktop, and server. Figure 9 has examples of network media. These are LAN media, WAN media, and wireless media, and cloud. These three components are the physical elements, you can touch it, or hardware of the network. Hardware is often the visible components of the network platform, such as a laptop, PC, switch, a router, and wireless access point, or the cabling used to connect the device. Some components may not be so visible. In the case of wireless media, messages are transmitted through the air using invisible radio frequency or infrared waves. So, if we want to know some of the end devices, network devices that people are most familiar with are called end devices or hosts. And these devices form the interface between users and underlying communication network. Some examples of end devices are computers, as you see here, workstations, for example, like laptops, file servers, and web servers. Network printers and telephones and teleconferencing equipment, and security cameras and mobile devices, such as smartphones, tablets, PDAs, and wireless debit credit card readers and barcode scanners. An end device or host is either the source or destination of a message transmitted over the network. In order to uniquely identify hosts, addresses are used. When a host initiates communication, it uses the address of the destination host to specify where the message should be sent. So, client and server software usually run on separate computers, but it is also possible for one computer to run both client and server software at the same time. And in small business and homes, many computers function as the servers and clients on the network. This type of network is called peer-to-peer networking. The simple definition or simplest peer-to-peer network consists of two directly connected computers using either a wired or wireless communication or connection. Multiple PCs can also be connected to create a larger peer-to-peer network, but this requires a network device such as a switch to interconnect the computers. The advantages are that it is easy to set up, less complex, and lower cost because network devices and dedicated servers may not be required and can be used for simple tasks such as transferring files and sharing printers. The main disadvantage of peer-to-peer environment is that the performance of a host can be slowed down if it is acting as both a client and a server at the same time. So, and we can say they have no centralized administration. They are not as secure, not scalable. How do you know that the network is working or not? Yeah, of course, there is a simple way. This is using the ping command. Every device that sends message across the network must have an internet protocol. You know, internet protocol is IP, and we are saying an IP address to identify it to the other devices in the network. IP addresses are assigned by the network administrators. When a new device is added to a network, or if an existing device is having problems, it may be necessary to test the network to determine if the IP address assigned to the device can be reached by other devices on the network. The ping utility tests end-to-end connectivity between the IP address of the source of the message and the IP address of its destination. It measures the time that it takes to test messages to make a round trip from the source to destination and whether or not the transmission is successful. So, however, if the message does not reach the destination or if delays are encountered along the way, there is no way to determine where the problem is located. So the format of the ping command, this ping command is universally implemented. Almost all network attached devices provide a way to perform a ping test. The format of the ping command is ping space XXX, where XXX is an IP address or domain name, like, for example, as you see on the screen, ping space 192.168.30.1, or you can write, if you know the web address, wping space www.google.com. The figure is an animation that shows two LANs, local area networks, separated over one. The animation demonstrates the ping command from a computer that's the name of the H1, and on one LAN, LAN, to a computer, and H2 on the other LAN, and the first computer has a caption, is H2 reachable, and sends a ping to 192.168.30.1, which is the address of H2. When the echo request reaches H2, H2 responds to H1 with an echo reply. The caption is, yes, I'm here. Yeah. So, if you want to try how to communicate two devices with the ping command, just go to command prompt and type ping with the IP number or domain name. Okay, just okay. Like on short clip, you can see at the end of these. Okay, at the end of this ping process, you can see that there is any connection problem with this address or not. If you enter Google domain name after ping command, you can see the IP address. Then you can try the same IP address instead of domain name after ping command. Okay, maybe if you try the same ping command with the domain name at the other time, maybe you can see the different address. Yeah. And the other term is trace route. The internet is not really a place, as you know. It is the interconnection of many different networks that provide services to the other users. We can see this connectivity by using a network utility called trace route. The trace route utility traces, the other name, watch or track, the route a message takes from its source to the destination. Each individual network through which the message travels is referred to as a hop. This hop is like trip. And trace route displays each hop along the way and the time it takes for the message to get to the network and back. So if a problem occurs, use the output of the trace route utility to help determine where a message was lost or delayed. And the trace route utility is called tracers. This is the code command in the Windows environment, like pin code. The figure shows an example of trace route from New York router to the London router to Paris router to Rome router over the network, over the internet. So I think we don't have too much time, just 3 minutes we have. Thank you very much for your participations. That was very difficult for me, but I tried that. Thank you. I hope if I have any mistakes, any words, I hope you can understand it. The next slide, if you have any questions, you can ask on any platform to follow new webinars and posts. Don't forget to subscribe alleducators.blogspot.com. And this is me, Ersin Tezbasaran. I'm one of the educators and I'm working as a computer science teacher at the senior school level. So I'm very happy to be with you and to be part of the education world. If you like, you can follow me on some of the social media platforms on the screen as you see. So let me check my chat box if we have anything. Okay. And about the slides, yes, but I'm thinking now I can take this recorded video to my website and to YouTube channel. You can see that from there. Slides is very original. I worked on maybe more than 1 month. Okay, thank you very much to you. Yeah. You're welcome. Okay, let me finish and end this seminar. Have a nice day, all of you.